Oh, hello everybody. Welcome to my project overview. So today I'm going to show you this project that I created, and the reason I created this project um, was because I recently passed my AWS Solutions Architecture exam, and I kind of wanted to demonstrate all the things I learned and implement it in a project. So let's just get started with the overview of the project. So the goal of this project was to do a simulation of a on-premise hybrid cloud database uh, to a cloud environment. And to do that, we have to uh, do a couple steps for setup. So the first step is we're going to use a cloud formation template provided by AWS that's actually going to generate some IoT sensors for us and create data for us. And we need this data for our pipeline. So let's just imagine that we have these IoT sensors set up around a stadium and it's tracking motion data, right? Where people are moving, where the traffic's going. So that's the data we're going to be simulating. Now, that data is going to be ingested into AWS IoT, which will just then be ingested into Kinesis Firehose. And Firehose is going to have two outputs. First is going to be the Lambda function, and the second is going to be an S3 bucket. An S3 bucket is our disaster recovery plan. In the event that Firehose fails or the data was, incorrect or it couldn't process data for whatever reason, we still have access to that data, so we're not losing any data. The second, the first output, Lambda function, is actually going to write to our MySQL database, which is hosted on an EC2 instance. This is all in a private subnet, right? Because we want to imagine that data was sensitive data. We don't want to have it going through the public internet. And so what I did was actually close off port 80 on MySQL database. And this gives us, secures our database basically. So the Lambda function actually needs to access the credentials of the SQL database in order to write to it. So in this private subnet, we have a VPC endpoint that will give us access to secrets manager. And Lambda will actually invoke those secrets to write to the MySQL database. Now, everything in this architecture has a IAM policy or IAM role in it. To implement best security practices, right? Um, Now, because of this private subnet, we need a way to access MySQL DB. So we have in the public subnet two bastion hosts, right? And these two bastion hosts only one of them is needed to connect to the database. The second one is actually used to use a tool called the schema conversion tool that will help us convert our MySQL schema into a Postgres schema. And we're securely accessing these two bastion hosts through the AWS SSM, so that's the session manager. And basically what we're doing is from our client, we're port forwarding here to our bastion host, and then our bastion host will actually port forward to 3306. That's the port on the MySQL database, and that's where the security group is. That's the only what do we call it, inbound rule for the MySQL database. And then the inbound rule for the Postgres is on port 5432. And this ensures that these are the only ports that can be accessed. Um, so once we have we access our MySQL database and the Postgres, we actually just want to convert the schema using uh, the schema conversion tool. The reason we're using the Windows server is because the schema conversion tool has a great UI that we can use, and I don't believe it's available on the Linux server. So we want to use that UI. It just makes things easier. So this is only converting the schema. To actually transfer the data, we're using AWS DMS. That's the database migration service, which is actually transfer the data. Um, and then that data will be written to the Postgres database, and then it'll also be written to an S3 bucket. Now, the reason we're writing to another S3 bucket is we might want to query that cold data, right? Maybe the hot data is in the serverless architecture where we can query this right away. But maybe that cold data, we want to perform some jobs on it, do an Athena query on it. So one thing I did was implement a glue job that's running on Spark, Apache Spark, and that Apache Spark is going to output is going to do an ETL process, going to output that data into TimeStream. So TimeStream is a new service by AWS that actually requires the unit of time to be in Unix time. So I did a transformation job using the glue to output it here. And then I also did a transformation job to make this a CSV with headers. I believe when I wrote that data uh, to this S3 bucket here, it didn't have headers on it. So I did include that with um, the new output. And then that data can be queried with Athena, and dashboards can be created from that. Now, the goal of this project wasn't about data analytics, it was more about the architecture. So this is just more of a side thing, but it is there. And that's basically the end goal, right? All of this architecture is to get to this end goal over here. So now I'm just going to demonstrate how this project was created. So one thing uh, was all of this was created not in the AWS console. Actually, I would say maybe two or three services. I think the DMS and the glue were created on the console, but most of it was written as infrastructure as code, right? So here I'm using Terraform to create all of my infrastructure. And what's great about Terraform is we can destroy everything at the end by just one command. So we're not, racking up a build here. So yeah, this is the project. It's all in the GitHub. This is the infrastructure here, and I have the, additional files. The README will be there on how the architecture works, and even this diagram will be all in there. Now, for the actual project, I'm just going to demonstrate how it's working. So first, I'm actually in an SSM session right now, and this is my SQL database, and I just want to take a look at how many rows I have in the database. So right now I have about 20,000 rows, 19,558 rows. And I want to start adding rows to this database, adding data. So we're going to do a device, some data simulation. So this is sorry, let me just go back and create a simulation. This is the web page that's created for us using the IoT CloudFormation provided by AWS. If you want to add a simulation, you can call this test 5. And I have a JSON file that has all the data set up on how the output should look like. Let's say we want to have 20 devices simulating data for us, and we want to run this for 300 seconds, and every second we're outputting data. This is the data intervals. I'm going to save this. I'm going to start simulating on test 5. And there we go. So now you can see the data is being simulated for us, and it's going to be ingested into Firehose. Now, Firehose is not a real-time data streaming service. It's near real-time. So there's a 60-second buffer or a 1 minute, a 1 megabyte buffer for the data to actually be ingested into Firehose. So this might take a minute, but we can see from our previous invocations the data that was processed through Lambda, right? So let's just go to that Lambda function. So this is the Lambda function, and just gonna briefly go over the code here. First thing we're gonna do is retrieve our secrets from the secrets manager, and you need to create environment variables to go and retrieve those secrets. So if you go to configure and you go environment variables, this is the location where my secrets are being held in secrets manager. Going back to the code, uh, and this is just the actual event handler here. And it's very simple. Data is going to be written to the MySQL database using PyMySQL library. And the data is going to be deserialized from the JSON format, and then then written. One thing that we did do is when we have a successful, or the data is successfully written, we're actually writing back to Kinesis to let Kinesis know the data was processed successfully, and if it was an error, Kinesis will actually then go back and actually write that data into the S3 bucket. So that's just one step we had to implement. I had to implement, and I can show you an example of that. So this is uh, the errors bucket, errors processing, which failed. And when I was testing this, I did have a couple failed events, and we can see the file here with the data that failed. Then let's go take a look at the instances that we have running now. We have three. So this is the MySQL database and the two bashing hosts. So I'm going to show you the Windows bashing host. So if you go over here, and you can see here, I'm actually, I remote desktop into this host here, and you can see all the credentials on the top here. And this is the tool, the schema conversion tool we're using. So let's just show you. This is the UI, and it makes it very easy to convert your schemas from, it could be, for my case, it's MySQL to Postgres, but it could be MySQL to, I don't know, a Redshift database, or any database really that the tool supports. And basically, I did a simple conversion. I didn't really do much on the data conversion. I have one rule, which is actually just changing the prefix of the table title, a table name, sorry. So, and that's just, this is just for, a simulation purpose. So, and one cool thing about um, sorry, the, uh, the tool is we actually can get a report. And in this report, you can email it to yourself. It shows you what was converted, and if there was any difficulties or errors, it shows you what wasn't, and you would have to do a manual intervention at that point. Um, so this is a pretty cool tool where you can get this cool report. Um, but that's basically it for this tool. We really, after the conversion is completed, we really don't need this Bastion host anymore. Now for the second part, let's just go over here to the DMS. So now you can see we have two tasks running on the DMS. The first task is to replicate the current and ongoing data. So any new data being written to MySQL will also be replicated. So we have two outputs here. So this is from MySQL to Postgres, and the second one is MySQL to S3. And these two jobs are going to be running until I shut it down. And then finally, this is the notebook I have written here. And I'm not going to run the notebook because I do have to set up the instance, and it does take a minute to start up. But you can see that I'm just rewriting the data with a header to the new S3 bucket, and I converted this timestamp to Unix for that that new database from AWS is the TimeStream database, and that was just me testing out that product. But yeah, let's just see. If you remember here, we had 19,558 rows. Now, if we go and do a select count on it, now we have 24,000 rows. So that data was input it into the MySQL database. Now let's go take a look at the Postgres database. So I'm using dbeaver here to connect to that instance, to the Postgres database. And if I do a count on Postgres, okay, well, I have a timeout here. Let's just make sure that my port forward. Okay, so yeah, here's the error. My session ended with the port forwarding. I just have to restart it. And I guess sometimes it requires me to create a new script. Let's just paste this here and run this. And now we have the same amount of rows in our Postgres database, right? So 24,379. And yeah, that's just basically the project. Like I said, this wasn't a data analytics project. It was more of a data engineering, data architecture project. While we could do, I did do a Athena query, but there's nothing really to show there. That's a very simple query we can do, and we can maybe do some dashboarding. Yeah, and that's the project. If you guys have any feedback or questions, you can always email me at my email. And yeah, thanks again.